Hello, guys. Today we are going to try to solve Leetcode 417 Pacific Atlantic Water. Basically, what this problem states is that these columns in this matrix represent the height above sea level of a land, right? And these borders, the blue one represent Pacific Ocean, and then the down here also represent Atlantic Ocean. Now, water flows from when it rains, water can flow from any of these lands into a Pacific or Atlantic Ocean. But water can only flow naturally. Water will flow from high level to down levels and then into the oceans. And water flows to all of these oceans. But we want to find uh, the cells that contribute water to flow to both oceans, both Pacific and Atlantic, right? So um, we have here water flowing from, this is a higher ground to a lower ground to a lower ground here. And by this point, water is flowing into Pacific. At this point, the same water from here is also flowing into Atlantic Ocean, right? So one thing we can all agree is that at column 0 down here, all the rows in this column are flowing water into Pacific. At row 0, all water in this column, in this row 0, and all these columns are flowing into Pacific Oceans. And here, the same applies to this. What we can also see that all these points over here have no in degrees coming into them, right? If you are you look at it from that point of view, these are all directly connected to the ocean. So these are points that we can start from. But we know that if we start from this point and we look left, right, or down, right, water, we can only receive water into this one if we are on a higher ground here. Water can be received in any of these cells if we are on a higher ground. So basically we can do a DFS, and this is a graphical representation of a graph. Let me point that out. So this is basically a graph question, right? And then we can use DFS or BFS to solve this question. Basically, first we have to gather all these coordinates or all these land levels that contribute water into both Pacific and Atlantic Oceans individually, and then we traverse left, right, down, or up to see if the row or the next land adjacent to it is higher and is flowing water through it. And then after that, we will find the intersection of cells that are contributing water into Pacific and cells that are contributing water to Atlantic. And then we get our answer, right? It's basically a DFS and then a little bit of intersection coding over there. So I'm going to go to the solution and then see how we can solve this question. So first of all, let's get the rows and columns, the length of the rows and columns. So this is rows is equal to length of heights. Cols is equal to length of heights. Right. Now for each row in rows. Now let's form a queue. We are going, like I said earlier, I'm going to use DFS. So, BFS, breadth-first search, to solve the solution. You can also use DFS, right? And you can try that out after. So let's form our queue. First, we have our Pacific queue. And our Atlantic queue. So for each range row in rows, Pacific dot append a row and column. Now we are going row by row, row by row, row by row, row by row. Now we know that this row keeps changing, right? But the column remains the same. So all of this spot is contributing, is flowing water into Pacific. So row is going to remain the same, and then column is going to be 0, right? And then we come to Atlantic dot append. Here we know that the column, so we are moving row by row, row by row, row by row, row by row. Here is where row contributes water into the Atlantic. Here is where row contributes water into Atlantic, and here is where row contributes water into Pacific. So here we're trying to get Atlantic. We know that this is the last column, but the row keeps changing. So it's going to be row, the last column, which is this, right? Similar thing is going to happen for columns. Right, we do the Pacific dot append. Now we are moving column by column. We know at row 0 this is contributing, so the row remains at 0, and then the column changes. For Atlantic, the row, this is the last row here, but the columns keeps changing, right? So rows -1, and then the column keeps changing. So now we've collected, where this is what I can say, we've collected all coordinates or all nodes in a graph that have in degree of 0. Those are like starting points, I would assume. So now let's put together our BFS algorithm, right? We need just the queue, and then we need to set visitors, which is a set. Now while queue, right, so we pop left, so row and column is equal to queue dot pop left, visited dot add row and column. Now we want to move up, down, left or right, and that can be represented this way. Right, 0 1 1 0, -1 0, and 1 0 -1. So anytime we move from say 3 to 5, the coordinates are going to change, right? So this, I'm going to call it adjacent row. It's going to be row plus dx, and the adjacent call is going to be call plus dy. The next step is there are certain conditions. This adjacent row and column must be within bounds, right? It doesn't have to fall into the ocean. It has to be within the range of the matrix. So let's check that out. If ATJ row is less than rows, or is greater or equal to 0 is within bounds. The same thing for columns. And if we have not already visited that cell, now if the new cell that we have got into is greater or equal to the cell that we came from, then now we can add it to the queue because it's a valid cell that is contributing water to whether the Pacific or the Atlantic, depending on which queue we are using this BFS algorithm for. And then we return visited. Right? Now let's get the path that sends water to Pacific and then Atlantic. We get that by calling our BFS and then calling Pacific. And then we get our Atlantic path. Now we return the intersection between the two. So there'll be a list of Pacific path dot intersection Atlantic path. So let's see if this solution works. Probably going to get some errors here. So Pacific is spelled wrong. Hopefully that's the only thing that is wrong here. Indentation. I got hit with indentation. Some indentation happening here. Another spell check. So Atlantic path, it says Atlantic path. Oh, how did I spell Atlantic wrong? Return list of Pacific path. The name Atlantic paths. Oh, my spelling here is wrong. All right. So besides these few spell check and indentation error, this is how you solve Pacific Atlantic waterfall. Thank you. Bye-bye.